Ruckus seems to have joined us for a little video tonight. Not sure where he's headed, but anyway, there he goes. Crazy little dog. So what we're going to look at, and it's typical night here in North Alabama. It's hot in the daytime, about 90 degrees often. So at nighttime, it's 8 o'clock now. Let's see exactly, 8:37 actually. So I try to do my little projects and everything when it's a little cooler outside, and it's better at the moment than it is during the daytime for sure. So what we have here is a 31.5-inch piece of reclaimed oak, and as you can see, it's just about the max capacity of the machine. When I set mine up, I took a straight edge and drew a red line down to the back. I think you can see that. Yeah, right about there. Yeah, you can see where it's. Anyway, the mounts for the machine that are very well defined, so we know pretty close to what our limits are. And tonight, what we're going to be using is this 1.25" carbide insert facing tool, and it was like 40 bucks on Amazon. I've been absolutely enamored with the thing. It's a great tool for the money, no doubt about it. So what we're going to do shortly is face off this piece of reclaimed oak, and luckily it's, as you can tell, it's pretty thick. It's a little over 1 inch thick there. When I measured it, it came in at 1 inch and something on the order of 1 inch and 50 thousandths, something like that. But plenty of material there for us to get it nice and flat on both sides. What we're going to have to do to get rid of this bow, I'm not sure how well you can see that, but yeah, there's a whole lot of, maybe the light will help. Typically does with that. There we go. Okay, so the good old gooseneck lamp. Yeah, you can see that now. This is your typical. Yeah, look at that. I mean, a whole bunch of bow. And we'll get every bit of that out. And that in and of itself is no amazing feat, but we will get every bit of that bow out quickly with that tool. We are running at a whopping 1,100 inches per minute. Let's just make sure of that. I'm using easel. So let's have a look at the cut settings here. Sorry for the bobbling. Yeah, the bit is 1.25 inches, as you can see there, and the cut settings. I've actually bumped it up to 1,400. That's very blurry. This is not going to be quite the video I had hoped it would be. Yeah, if you can see that, 1,400 inches per minute. Now that's pretty smoking fast in anybody's book, or at least here where I do my work. 1,400 is the highest I've ever run on anything, but that bit will take that, and I will top it out at some point. We may hit 2,000 inches per minute before it's all over with. So what I wanted to cover here tonight was, as you can tell, we got a lot of bow in the board, whole bunch of bow to take out. So the clamps I'm using, let's start with, why are we not back here at the stop? Well, you can see pretty quickly, this is my X-axis stop, and typically what I would do is take the workpiece and just stick it right up against that, and down here too, and if needed, I'll run these screws through the stop and into the workpiece to hold it in place. That really helps when you're doing stuff like getting rid of a bow. So tonight though, this one is too long for that. If I were to put it here, we come down to this end and we exceed the length that the machine will cut. So what we have to do is, we're actually using this for a stop. In other words, we can't move the workpiece any farther this direction. We don't want the tool to push it that direction, so we have this. This is basically a piece of oak. Let's move around to that side. It's basically just a round piece of oak, drill a hole through it, and cut a flat to mate up with the wood here. So we may actually shave a little bit off the plastic nut there, but I'm not too worried about that. I come up with these round shapes fairly often. And one example, there's one. I forget what I cut that out of. It's also oak, but I use it for a coaster. Pretty handy. I should have actually cut some out so it would catch all the condensation that comes off my glass, because here in North Alabama the humidity is outrageous, so that they do a lot of sweating. So okay, so we've got this stop in place to keep the machine from pushing the workpiece that direction, and our x-axis stop is actually end of it is what we're using to keep it from pushing the opposite direction. You might ask, well, what's this guy for? These are really cool, also very economical purchase. They're just a piece of steel with a bend in the middle, probably a 10-degree or so bend. And the way it works is you stick that little guy up next to your workpiece and run a screw in it, and it pushes down and forward. And that sticks the prongs into the workpiece just a little bit. You can see they're just barely going in there. But it's an amazing amount of force that just the right amount of force. I mean, there's just no two ways about it. This is a very, very useful clamp. So that's what's holding the workpiece down. It's on this end, it's secured in the x-axis. Sorry, that would be the y-axis. And because we're putting enough downforce on it, it also doesn't slide left or right in the x-axis. Now, to address the bow, if we just ran the tool across it, the workpiece would probably flex, and you would end up, the tool itself would push down, and then when the tool went on past, the thing would come back up. So that would never work. I may as well run it through a planer if we were going to do that. You'll never get the bow out. You'll just end up cutting up all of your material, and the more you cut away, the weaker it gets, and the more the bow persists. So what we're doing here, this is, I'm sure you guys have seen this type of clamp. This is simply one of the, you know what, let's not pull that one out. You can see pretty well what it is. There's one just like it over here. This is one of the clamps that you put up against a workpiece and turn like a handle, and it's like a cam lobe, and it puts force laterally on the workpiece. But what I'm doing, I made mine where they're sort of a dual purpose type clamp. This is a tapered edge on a lot of them I've seen is just cut square right there. Well, I put mine on a drum sander so that I could get a taper on this end, and I'll slide that up under the high spot where it's bowed, and then tighten that down. And basically down here we have the same thing. We're pushing down. This stop prevents it from moving this direction, and this is your typical aluminum clamp that's typically used for hold down purposes, and I'm just using it to keep it from pushing the workpiece that direction. And it's in there good, and I would move the whole table before that thing would move. You cannot beat it. It will absolutely, this entire workpiece, and I think I've got it set up for 4 passes. It would take maybe, I think, about 8 minutes to do the whole thing. It's 31 by 6, I think. So anyway, if that's the type of work you do, that tool is well worth the money, and I'll leave a link to it in the description. Okay, so we have used the maximum capacity of the tool with one exception. I'm sorry, of the machine with one exception. The cut is 32 inches long. So if we took our tape measure and measured from that end to that end, we would in fact see 32 inches as evidenced by the tape measure. However, if we wanted to, we could have, using this tool anyway, we could have cut just a little bit more. Had I compensated for the radius of the tool, in this case it's 3/4 of an inch, I could have actually added, gone into easel and said, make this cut 32 3/4 inches, and it theoretically it would have worked just fine because the spindle will move 32 inches, and when you add the radius of the tool, of course, you get 32 3/4. The reason you don't do that on both ends is because back on this side, see if I can turn this camera without it being, yeah, this normally makes a terrible racket, but anyway, if we if we move to the X origin, we can see that we're right at the limit right here. If we went any farther, we'd be hitting the stop. So if you set your X origin right there, you don't have any more room for the gantry to move. Well, the gantry moves on the Y rails, but the spindle will not move any more this direction because it will literally hit the stop right there. But what you can do is add the 3/4 of an inch, and it'll cover that or remove that down on the far end. So anyway, while I have the opportunity, we'll remove this support / cam clamp, and as you can see, it's got a nice little feature that lets you get up under things with bows. I probably will eventually add a little bit more or take a little bit more off that so I can get under work pieces like that further. But how I did that is I have a spindle sander, and the drum moves up and down, and the sanding, the drum just spins on this surface here, and stay at it for a minute or two, and you end up with this pretty neat feature. It's nice and smooth. You don't catch your fingers on it like I did here and cut myself on another piece. That's gonna happen. I don't care how careful you are, that's gonna happen from time to time. But anyway, hope this helps anybody working on, this is very common with reclaimed stuff. Reclaimed is usually pretty cheap to get your hands on if you do it in volume. It makes for some gorgeous finished work, just some absolutely, you can't get this at Lowe's. You can't get wood at Lowe's or Home Depot or any of the big box places and come out with the 100-year-old looking finished work pieces. It just doesn't happen. I've never seen a technique that you could spend your time on. You know, the time is another factor too. If you invest another hour or two in making the material look reclaimed or weathered or whatever, you know, whatever your goal is, you've also invested that much more time in it too. So anyway, hope this helps cover some things that, especially the bowed twisted wood is a whole nother story. You can do it too. I'll do a video on that sometime, but we'll find us a nice nasty twisted 2x8, 2x6, something real good and thick and sturdy, and maybe we'll do that in the next video. But thanks for checking it out. We'll catch you next time.